In this example, we're going to continue practicing indefinite integration using the three rules that we've covered so far. For this example, we can start by separating each piece using rule 3, removing the constants using rule 2, and then integrating the remaining variables or the remaining functions. So in this case, we end up with the 5 times. We can do step 3 and rule 3 and rule 2 together. Remove the constant. We notice there's brackets around this because the dx goes with each term when we separate it. Minus 6x squared dx plus 1 we don't need to write, so we just write the integral of dx. Integrating gives us 5x to the 4 over 4 minus 6x to the 3 over 3 plus x plus a constant. Simplifying reduces this to a 2 and everything else stays the same to give a final answer of 5x to the 4 over 4 minus 2x cubed plus x plus a constant. The next example is actually using less rules, but needs to be rewritten to integrate. So we can take the constant out first. The 5th root of x squared is in the denominator, so we can write it as x to the 5 over 2, make it negative to take it up top. And now it's simply a matter of using rule 1. So all we did here, we rewrote the denominator as x to the 2 over 5, made it negative to take it up top, took the 3 outside. We integrate now, becomes 3 times x. Let's write the whole step here. The exponent is increased by 1, and the denominator is the same as the exponent plus a constant. That becomes 3x to the 3 over 5 over 3 over 5 plus a constant. These 3's are going to cancel. The 5 is going to come up. We end up with 5x to the 3 over 5 plus a constant. This example, we notice we have not only an x squared, but the whole binomial term here is squared. To do that, we need to simplify this expression first. That gives us 4x to the 4 plus 4x squared plus 1, just by doing the algebra, squaring this bracket. Now we can separate the terms, remove the constants, and integrate. Hopefully we've seen enough practice now that we can do that without actually having to write those 2 middle steps. So treat each term separately, remembering you're taking your constant out. So we have the 4 that stays, the x becomes to the 5 over 5, plus the 4 stays, x becomes to the 3 over 3. The integral of 1 dx, or the integral of dx, is just x, and that's plus a constant. So as we do enough practice, hopefully we won't actually have to write the step where we use rule 3 and rule 2. We just work straight from there. So this is the final answer.